Hello guys, so in this video I'm going to go over how to find whether the series converges or diverges through the ratio test. So how do I know to use the ratio test? So I know to use the ratio test because I have a factorial, and most times when you have an n factorial, you apply the ratio test, and not just n factorial, but any n term to a factorial power, you apply the ratio test. And that's not always, that's just most of the time. So it's always good to link those together. Whenever you have factorial, you apply the ratio test, which I forgot to actually write. Yeah, ratio test. All right. So what is the ratio test? So basically in the ratio test, we have a formula which is right here, which is the limit of the absolute value of a sub n plus 1 divided by a sub n is equal to L. So the first thing we're going to do in step 1 is we're going to identify all our variables. So step 1, we're identify all variables. So what are the variables in this case? The variables in this case are, every time we're doing the ratio test, the variables in this case are a sub n and a sub n plus 1. So what is a sub n? A sub n is simply just what we're given, as noted here. So a sub n is 3n divided by n factorial. A sub n plus 1, however, we add 1 everywhere we see n. So 3n plus 1 divided by n plus 1 factorial. So now that we have that, for our next step, in step 2, is we're going to apply the formula. So for step 2, we're going to apply the ratio test. So in doing so, we're going to take the limit as n approaches infinity of a sub n plus 1 divided by a sub n. So I'm going to go ahead and write that here. The limit as n approaches infinity of a sub n plus 1 divided by a sub n is equal to L. And whatever our L is, we have these conditions right here that we apply, and they're the same as the root test. And based on whatever our L comes out to be, we'll determine whether this series converges or diverges. So without further ado, a sub n plus 1 is over here, and a sub n is over here. So now all we simply do is just plug these two in, and then take the limit, compute the limit. So the limit as n approaches infinity of a sub n is 3n plus 1 divided by n plus 1 times 1 over a sub n. So for a sub n, it's 3n, but what we're going to do here is, and I'm going to write a line to separate these two, is we're going to go ahead and just reciprocate this because it's on the bottom. So we're going to reciprocate it in this step right here. So n factorial divided by 3 raised to the n. So now what we're going to do is, in step 3, we're going to go ahead and we're going to distribute out all terms and line them up. Why? Well, you will see. So right here, let me make this more clear. So we're going to distribute all the terms and we're going to line them up. So that's our step 3. So notice right here we can actually distribute a lot of terms out. So the limit as n goes to infinity of 3n plus 1, 3n plus 1 can be rewritten as 3 of n times 3 of 1 times n factorial divided by n plus 1 can be rewritten as n factorial times n plus 1 times 3 to the n. And now we distributed all the terms. Check. So now the next step is we're going to go ahead and, as I wrote, we're going to line them up. Why? Because it makes it easier. That's why. So now that we have them, we're going to go ahead and line them up. So the limit as n goes to infinity of the function so the limit as n approaches infinity of 3 of n divided by 3 of n. And all I'm simply doing is uniting the like terms. So these terms are going to go together, and then these terms are going to go together, and whatever is left over is left over. So 3 of n times, the next terms are the n factorials. N factorial, make sure that's divided by n factorial times, so we got these down, we got these down, and what's left is 3 raised to the 1 power times n divided by n plus 1. So whenever we simplify this, because now we can simplify this, 3 of n cancels, n factorial cancels, and we're left with the limit as n approaches infinity of 3 divided by n plus 1. So now all we simply do is just plug in our n to see what we get. So this is equal to 3 to the 1 power is simply 3 divided by n plus 1 would be infinity plus 1, which is equal to 3 over infinity because the 1 is very insignificant. And this is equal to 0. So our L is equal to 0. And now in step 4, now that we have L, I'm going to go ahead and put a box around it. Now that we have our L in step 4, all we simply do is just apply the ratio test conditions. That's all we have to do. So what are the conditions? Well, I did mention them earlier, but now I'm going to go ahead and drag them all the way down here. So these are our ratio test conditions. Now our L came out to be equal to 0. And since L is less than 1, we can say that this whole series converges. Converges by ratio test. And that's our final answer. So basically all we did was simply in step 1, which I'm going to quickly go back through this problem in retrospect. In step 1, which all we did was identify a sub n and a sub n plus 1. And how did we identify a sub n plus 1? Well, I'll make a note of it real quick. So for a sub n plus 1, all we did was just add 1 to all n terms. And notice how that 1 is inside the factorial, not outside. So keep that in mind as well. So that's how we identified our a sub n plus 1. And then from there on, in step 2, we just applied the ratio test. Knowing that we were going to apply it, we're going to take the limit, find the limit L, and then from there, we distributed the an plus 1, and then we line up the terms, so that way they can cancel out. And that's what we did in this step. We lined up all the terms, and they canceled out very nicely for us. And then from there, in step 4, we found that L is equal to 0, because 3 divided by infinity, any constant over infinity is equal to 0. And since L is less than 1, this series converges by ratio tests. Thank you for watching. I hope that was helpful. Hello guys, so in this video, or in this example, we're going to find out how to apply the ratio test given this type of formula. So one thing I did make a note of is you want to apply the ratio test every single time that, or most times when you have n factorial, it means to apply the ratio test. Now notice on this term we don't have it, but that's just one note that I feel like people need to know. So when you see n factorial, apply ratio test. Right, so in the ratio test, we're given this formula right here, which is the limit as n goes to infinity of a sub 1 plus n divided by a sub n is equal to L. And whatever L is, we have these ratio test conditions, which are right here. And basically, we just apply whichever one based on what our L comes out to be. So the first thing we're going to do is, for step 1, is we're going to identify all the variables. So identify variables. So what are the variables for this? Well, in this case, the variables are a sub n and a sub n plus 1. So a sub n is just basically what we're given. So in this case, it's 3n times 7 raised to the nth power divided by 5 raised to the nth power. Then a sub n plus 1 is equal to 3 n plus 1. And notice how I put brackets, or notice how I put parentheses around the n, indicating that it's separate from the 3, and the 3 will be distributed to both terms. 7n plus 1, I'll put parentheses around it as well, so that way you can see what's going on, divided by 5n plus 1 parentheses. So that's our a sub n plus 1. So these two terms, I'm going to go ahead and box both of them because they're very important. A sub n, and then we have a sub n plus 1. And now the next step is, for step 2, is we're going to go ahead and apply ratio tests. And we're going to do this by computing the limit of a sub n plus 1 divided by a sub n. So we're just going to put computing the limit. So basically here, we have the formula as the limit as n goes to infinity of the absolute value of a sub n plus 1 divided by a sub n is equal to L. Where am I getting this from? I'm getting this from here. This formula right here. So that's the formula we use for ratio tests. So now I'm just rewriting it down here. So now the next step is we're going to go ahead and reciprocate a sub n. So we can rewrite this as the limit as n goes to infinity of a sub n plus 1 divided by 1 over a sub n. So that way we can remind ourselves that this is being reciprocated, that the a sub n is being reciprocated. So I can have room to scroll down. So right here, the limit as n goes to infinity of a sub n plus 1 would be 3 n plus. Here, I'll make it red. There we go. Now we can see what's happening. 3 n plus 1 times 7 exponent n plus 1 divided by 5 exponent n plus 1 times the reciprocal of a sub n would be 5n divided by 3n times 7 raised to the n power. So now that's step 2. All we did here was just compute the limit. Wow. So now step 3. For step 3, all we simply do is just a little bit of algebra. We distribute the terms and cancel stuff out. So that's what we do for step 3. Distribute the terms and cancel stuff out. So in doing so, we're going to go ahead and distribute all the terms out. So the limit as n approaches infinity of 3n plus 3, and this term is still together. Because there's a plus sign, I'm going to put parentheses. Otherwise, we would get a different answer. 7n times 7n plus 1, we can just put 7 to the 1 power. And we're just applying the exponential properties. Divided by 5n times 5 raised to the 1. And all this is being multiplied by a sub n. So 5n divided by 3n times 7 raised to the n. And this right here is the function that we're working with. So now, one thing I did forget to put is, and it makes it a lot easier, and I'm going to leave it as a note. So note, line up your terms before canceling out. Why? Because it prevents mistakes, because it makes it easier, and it's just the extra step that can assure that you won't get the incorrect answer. So line up your terms before canceling out. So that's what we're going to do in this next step right here. So we're going to go ahead and line up all these terms. So the limit as n approaches infinity of 3n plus 3, and since these are in parentheses, they're basically together, divided by which term lines up with it. So right here, I'm going to put circles color-coded so I know which term lines up with which. So 3n plus 3 lines up with 3n. 7n lines up with 7. 5 raised to the n power lines up with 5 raised to the n power. Then what we have left over, I'll leave it in red. So now we know what to line up with what. And I think that step is very important. You can skip it, you can try to cross things out as you see it, but I've also seen people make mistakes. So that's why I like to do this mini step, because it really does help, comes in handy. Times, oh, I just noticed I circled these with the same. So here 5 of n will be in the green circle. There we go. So now the next terms that we line up are 5 of n divided by 5 of n, and then we have 7 raised to the n divided by 7n times the terms that are remaining are, let's see, 7 to the 1 power divided by 5 to the 1 power. So now Why do we like to line things up? So we can see things cancel out properly and we know we're not making a mistake. So right here we can see that 5n divided by 5n cancels and 7n divided by 7n cancels. So we're left with 3n plus 3, the limit as n approaches infinity of 3n plus 3 divided by 3n. And this 7 over 5, it's a constant, so I actually can move it to the front, in front of the limit sign. So in doing so, when we plug in infinity for both terms, we get 3 infinity plus 3 divided by 3 infinity, which will give us infinity over infinity. And if you've been around calculus long enough, you know that this is basically just asking us to apply L'Hopital's rule. So we're going to put the little symbol for L'Hopital's rule. So in doing so, we get 7 divided by 5 as our constant, the limit as n approaches infinity of 3 of n. When we take the derivative of 3 of n, we get 3. The derivative of 3 is 0, and the derivative of the denominator is just 3, which is equal to 1. So essentially, L is equal to 1 times 7 divided by 5, or simply just 7 over 5. So this is what our L is equal to. So now that we know what L is, the next step is, so now that we have our L value, step 4 would just be to apply the ratio test conditions. So you might ask yourself, what are the conditions? Well, the conditions I already have, so all we simply need to do is just get them by scrolling up, or if you have them on your paper, that's good too. So copy, and then so these right here are 3 conditions. So if L is less than 1, converges. L is greater than 1, diverges. L is equal to 1, then we use another series test. And in this case, L is equal to 7 divided by 5, and 7 over 5 is clearly greater than 1. So since L is greater than 1, we can then say that since L is greater than 1, that this series will diverge. So we say diverges by ratio test. And that's our final answer. So in quick retrospect, what did we do? So the first thing we did was simply just identify the variables that we have over here. Our variables were a sub n and a sub n plus 1. Then in step 2, which we have right here, in step 2, we computed the limit. And in doing so, we did a lot of arithmetic. We distribute the terms out and we cancel them out by lining them up before we canceled out. And then in doing so, we got L was equal to 7 over 5. Then for step 4, we applied the conditions of the ratio test. So noting that L is greater than 1, this series diverges by ratio test. And that's how you apply the ratio test. Thank you for watching. I hope that was helpful.